Hi, welcome to Module 3. In this module, we will introduce conditional operations and loops in Python. The first part is if statement. If statement is the most commonly used conditional statement, allowing us to choose which statements to execute. Then, you may wonder how it works. If statement checks whether a given condition is met. When the condition is true, a set of codes will be executed. Otherwise, an alternative set of codes will be executed, or simply doing nothing. To understand how if statement works, let's type the following code. First, we want to ask the user, do you like learning Python from the scale of 1 to 100? And get the input. Scale is input. Do you like learning Python from the scale of 1 to 100? Then we convert string returns to float by typing scale is float scale. The next step is to form the if statement. We want to print good to know that you like it if the input is not less than 80. In this case, we type if scale larger than or equals to 80, colon, and then press enter. Print good to know that you like it. Out of the if statement, we print. Let's learn more about coding. For example, I input 100. The output is good to know that you like it because it is larger than 80, and it prints. Let's learn more about coding no matter how much the input is. The section of code to run when the condition is met has to be indented like here before print good to know that you like it. Indentation can simply make by pressing enter after the colon in an if statement. You can also make the indentation by tab or inserting spaces. More than one statement can be controlled by a conditional. Each statement should use the same indentation. You can simply press enter after the first statement to make the same indentation. For practice, let's insert a line to print a message. Please like and subscribe when scale is larger than or equals to 80. Let's run the code. Now you see that the output has please like and subscribe because the input 100 is larger than 80. Remember that Python is a case-sensitive language, so if with both letters in uppercase and if with I in uppercase are not working. The next conditional operation we introduce is else statement. Else statement allows you to perform an action when the given condition is not met. Please insert the following lines after printing the message. Please like and subscribe. So else, colon, print. The later chapters will be more interesting. Now we change the inputs to 60. And the output is the later chapters will be more interesting. Let's learn more about coding, since 60 is less than 80. An else statement should have the same indentation level as the if statement. To delete an indentation level, you can press Shift plus Tab or backspace. The action taken when the else condition is met has to have one indentation level higher than the else statement. If statement can be nested inside another if statement. Please be reminded that each pair of if statement and else statement should have the same indentation level. Let's try the following code for practice. As we did previously, we asked the user, do you like learning Python from the scale of 1 to 100 and convert the string to float. Then we add the conditions. For scale is larger than or equals to 80, we print good to know that you like it. So if scale greater than or equals to 80, print. And then for else, if scale is larger than or equals to 60, we print the later chapters will be more interesting. For scale is less than 60, we type else, print, cheer up, you will like it one day. As we mentioned earlier, if and else statement have the same indentation level, and remember to type colon after the if condition and else statement. Finally, we print, let's learn more about coding no matter how much the scale is. Now, let's run the code. For example, we type 100 here. The output is good to know that you like it because it is larger than 80. And it also prints, let's learn more about coding. Then, this time, let's try 65. The output is the later chapters will be more interesting because it is larger than 60 but less than 80. Then let's try 50. And then the output is cheer up, you will like it one day because it is less than 60. Now it's your turn to practice. Next, we are going to talk about else if statement, which help us to make nested if statements easier to code and read. Let's try the following codes. Please be reminded that if statement, else if statement, and else statement should have the same indentation level. The first four lines of codes are the same as the previous example, so we can simply copy it from the previous one. Now, we are going to use else if statement instead of else for scale is larger than or equals to 60. So, else if scale greater than equals to 60. Remember to put colon here and then press enter. The rest of the scale is less than 60, so we type else, print cheer up, you will like it one day. The last line of code is also same as the previous example. Now we can run the code. We also put 100 here as an example. The output is good to know that you like it and let's learn more about coding, which is the same as the previous example. Now let's try 65. The output is also same as the previous example. This time we try 50. And the output is cheer up, you'll like it one day, because it is less than 60. Now you know that else if statement is an alternative for the nested if statement. A good practice to code nested conditional statements is to write a flowchart before coding. Flowchart for the program in 3.4 is provided in the following diagram. If statement and else if statement are represented by a diamond shape to show two possible outcomes. The condition is written inside the box. An arrow line links conditional statements to actions to be performed. The path of the arrow line depends on the outcome of the conditional. It indicates which action should be performed. and the outcomes are written nearby the error line with values yes or no. Actions to be performed are represented by a square box. From the diagram, you can see that if scale is larger than or equals to 80, it prints good to know that you like it. If not, but scale is larger than or equals to 60, it prints the later chapters will be more interesting. If scale is less than 60, it prints cheer up, you will like it one day. In addition, no matter how much the scale is, it prints let's learn more about coding. The first type of loops we are going to introduce is while loop, which is used when we want to repeat a series of statements several times until a condition is not met. The body of the loop must be indented, and the body starts after the colon and ends by the first unindented line. Please try the following code. First, we want the user to input how much do you invest today, what is your annual return in percentage, and how much do you want to invest in the future. Then we convert strings to float and assign the values to the variables I, R, and T respectively. The year starts from 0, so if the investment is less than the target, we keep investing. Therefore, when the condition that I is smaller than T is true, the program keeps looping. So while I smaller than T, we calculate the investment after 1 year. The year increases by 1 each time, and we let the user know how much they will have in each year. So print after the loop ceases, we would like to inform the user how many years it takes to meet the financial targets. Let's run the code. For example, I invest 10,000 today, and the annual return is 5%. And I want to have 15,000 in the future. The output shows that it takes 9 years to meet the financial targets. It also displays the amounts I will have each year. Most of the time, while loop requires a statement to initialize a variable for counting purposes and another statement for increment. What if the input of annual return is 0? Then while loop could lead to endless iteration. You can press Ctrl plus C to interrupt an execution of the program. In Collab, you can click the run icon to stop the execution. Flowchart for the program is provided in the following diagram. The program keeps calculating the investment and increases year by 1 when the condition that I is smaller than T is true. If the condition is not true, it prints out the output. Then, let's talk about break. When the condition is true, the action in the loop will play repeatedly until a break statement. A break statement ends a loop in the middle of an execution. Let's replace statement since line 6 in 3.6 with the following code. First, we change the code to while true, which means to loop until the break statement. The following 3 lines of code are the same. As we just said, we stop investing when the investment is not less than the target. Therefore, the loop ends if I is greater than or equals to T. Then we type break to end the loop if the condition is true. The last line of code is the same. Then Run the code. Still, I invest 10,000 today, and then the annual return is 5%, and I want to have 50,000 in the future. You can see that the answer is the same as the previous example. Last but not least, the for statement iterates a series of statements over a sequence. The sequence starts from the first argument and ends up to but doesn't include the second argument. Please be reminded that the number in the range has to be an integer. Let's replace statement since line 3 in 3.6 with the following code. This time, we ask the user how many years do you want to invest instead of the financial target. As we mentioned earlier, the number in range has to be an integer, so we convert the string of the time into an integer. We use for statement to keep calculating the amount each year in the time range the user specifies. And then we would like to let the user know how much he or she will have after the specified years. Let's run the code. Still, I invest 10,000 today, and the annual return is 5. I want to invest for 6 years. Then the output shows you how much I will have after 6 years. You may wonder why the first element is set to be 0 and how many times the program ran. It will be easier to understand with an example. Here we insert a line of code to print the amount each year. If the first element is set to be 1 and the user inputs 6 as time, you can see that the program only runs 5 times, since the loop ends up to but does not include the second argument 6. Therefore, we set the first element to 0 and the program runs 6 times. One characteristic of for statement is that it does not require setting up a variable for counting purposes. Flowchart for the program is provided in the following diagram. If x is smaller than time, the program keeps calculating the investment and increases x by 1. If x is not smaller than time, it prints out the output. Please practice the following exercises. Having watched this video, I hope that you could grasp the concept of conditional operations and loops. Thank you for watching, and look forward to seeing you in the next module.